Welcome to Systems Analysis and Design. This will be a textbook-driven course, and much of the work we'll be doing will be review questions from the ends of each chapter. These are the slides from the textbook. I'm going to be going through them somewhat quickly. If you read through the actual text and read the chapters as we go on like you're supposed to through this class, you should have no trouble following along. However, there are some items in this textbook that I want to comment on, especially some good, some not good. Just personal experience, what I've seen. I'm going to teach this course objectively, but I am going to call out some of the things that concern me. And I'm also going to praise some of the things in this textbook that really are beneficial and that I think work really well. So that being said, I'd like to move on to the chapter objectives. Describe the impact of information technology. We're going to define systems analysis and design and the role of the systems analyst. We're going to define an information system and describe its components. We're going to explain how to use business profiles and models. And we're going to explain internet business strategies and relationships, including B2C and B2B. So before I move on, let's touch base on a couple things here. When we define an information system, this is definitely not just a computer. There's more to it than that. In fact, there's about 5 components. We're going to go through those in a later slide. And also B2C and B2B. If you're saying, hey, I don't know what that is, I'm going to tell you briefly right now. It's business to consumer and business to business. And again, we're going to go through that in a little bit more detail as we move on. So continuing with the chapter objectives, we're going to identify various types of information system and explain who uses them. We're going to distinguish among structured analysis, object-oriented analysis, and agile methods. Again, the textbook goes into agile methods. I've seen this work badly and I've seen this work very well. I'm going to cover the waterfall model and how it's evolved throughout time. We're going to discuss the role of the information technology department and the systems analysts who work there. I think that's an important thing to point out, is who work there. A lot of times I think systems analysts are bought into a situation as consultants, and I think sometimes it's good to have somebody on the ground who knows things and knows the history of the company to some degree. Now for the introduction. So companies use information as a weapon to battle, and a weapon in the battle to increase productivity, deliver quality products and services, maintain customer loyalty, and make sound decisions. And information technology can mean the difference between success and failure. The biggest example I've ever seen of something like this is the Obamacare rollout with the government website. If you recall, and if you don't, there's lots and lots of articles on it out there, just Google it, that concerned the failure in the rollout of the website for Obamacare. To me, I would hate to be in a situation when that happened. Think about all the media coverage that those systems analysts were receiving and how much pressure they got from their boss. And think how critical it was that they were answering directly to the President of the United States because his signature piece of legislation was being held up because of an IT failure. So that's one reason I feel this class is important. I don't ever want to be the person in a situation like that, and I've worked very hard to teach as much about this as I can because I have seen failure. And it's not fun. So I wanted to go on to what is information technology. Information technology is the combination of hardware and software products and services that companies use to manage, access, communicate, and share information. And we got this here, welcome to the 21st century, the IT journey continues. So obviously there's changes all the time. And that's about it. Thank you. Now let's discuss the question of what is information technology. First, let's start off with systems analysis and design. Systems analysis and design is the step-by-step process for developing high-quality information systems. We're also, in later chapters, going to talk about the SDLC, which is the life cycle. What does a systems analyst do? Since this is the role we're going to be playing in this class, we should know what they do. They plan, develop, and maintain information systems. In other words, they really kind of work between the end user and the engineers or the software developers to ensure that everything works smoothly and to make sure that things go as planned, and to handle things like resource allocation, costing, projects. And one thing that always comes to my mind that is not mentioned here is a systems analyst also needs to be involved with doing major systems upgrades, which is very common. And when I actually think about this course, that's when it becomes the most relevant, is when you're doing a major systems upgrade, whether it be with the same vendor or whether it's with a brand new vendor. So those are roles that systems analysts handle. And by doing that, they also conduct meetings, deliver presentation, write memos, reports, and documentation. This kind of sounds like something that a project manager might do, and that's true. A systems analyst does serve a lot of the same role as project managers. However, their skill set and their knowledge is much more specific to IT as a whole, and there's methodologies that exist that a systems analyst would use that a project manager would never use. So that being said, let's go on and discuss the different components of the information system. So an information system is a system that is a set of related components, and it produces specific results. Its mission: critical systems are vital to a company's operation. At Albertus, we have our student information system, which handles everything. It handles financial aid, it handles grades, classroom assignments, it handles professors and faculty information, it handles student information. I could go on and on. It also handles the college finance. So these systems are mission critical, as you know. And the 5 components which we mentioned earlier, I'll list them off now. There's hardware, software, data, processes, and people. And yes, people make a big difference, and it is considered part of the system. Different people provide different inputs. Some people don't provide inputs at all. I would say the lower, more supervisory positions, I'd say a lot of your clerical positions, they provide a lot of input to the system, where more higher and managers and vice presidents and people like that, they'll absorb and read the information and pull it out, but they're all part of the information system. So with hardware, it's the physical layer. In other words, it's the physical bare metal systems that exist, and a lot of them are set up in server farms, tower system. There's tower servers, there's all different types of servers, and it really depends on your company and your information system. Next, we look at Moore's Law. So the definition of Moore's Law is the principle that the speed and capability of computers can be expected to double every 2 years as a result of increases in the number of transistors a microchip can contain. So I received this information here from the American microchip manufacturer Gordon Earl Moore, who proposed such an idea. So that's where it came from. I found this by doing a Microsoft search. Continuing on, we'll discuss the other 3 components of the information system. There's data. So tables in databases store data. Linked tables work together to supply data. Processes describe the tasks and business functions that users, managers, and IT staff managers to perform and achieve specific results. Oftentimes they'll have an operator who is strictly in charge of running these processes under the direction of IT staff members, managers, and etc. And the people are the stakeholders. That could mean the stakeholders, that could mean an investor, that could mean a shareholder, that could mean an employee. Anybody who has a stake in the business is part of the information system, and that obviously includes users and or end users. Business in the 21st century, 3 major trends. Rapidly increasing globalization. We hear about this with Trump and his tariffs with China all the time. That is definitely a global trend. No matter how many tariffs we put out there, we're still working towards a globalized market. Technology integration for seamless information access. More and more devices are driven by computers than ever before. I've seen washing machines that were controlled through phones nowadays. I can't even figure out the reason for that. Rapid growth of cloud-based computing and services. There's Azure, there's AWS, as well as many other cloud platforms. And all trends are internet-centric and driven by the power of the web. We also hear about i-commerce or e-commerce. That's electronic commerce. There's business to consumer, there's business to business, there's EDI, supply chain management, supplier relationship management, and what's next? I mean, phones are getting more and more complex and more detailed. Business is starting to be conducted more and more on phones and smaller devices now than it ever has been before. So, something else to consider there. There's internet-dependent firms where their primary business depends on the internet rather than the traditional business channels. Amazon is a great example of that. Amazon does really not exist in brick and mortar stores, although they actually are starting to work towards that now. Brick and mortar stores also have need for information systems. Stores such as Walmart, Costco, Target, Home Depot, what have you. So the web-based business model leveled the playing field for smaller firms that now can reach a global marketplace. Is there anything that affects this global marketplace? I think, and I'm not going to take a side one way or the other, but I think if you look at net neutrality, that really kind of goes along with this bullet point. I'd like to have seen that discussed a little bit more, but I'm not going to go into it. Discount coupon businesses get new life. eBay and Groupon, Amazon. Firms are now using global positioning system or GPS coordinates to tempt buyers with nearby deals, and I'm sure Amazon does that. My products get there way too quickly. So here's a simple business model on how a sale might exist. You might have an event or where you receive a sales order. You process it and check the customer status, verify the credit. These are the different processes that could go ahead, and then the result is a completed sales order. So this is a very simple example of business process modeling, and we'll go on to the next slide. Continuing on with business in the 21st century, we can look back at business information systems in the old way, which is where the administrative staff use their office systems. They'd have their data entry systems, which would likely upload information to a larger machine. Operational people used operational systems where they took the administrative staff's data and
made use of it, and that data was converted to information which were used in DSS, or decision support systems, by middle managers. And top managers, they were more concerned with very much more summary type of information. Nowadays, top managers like to see dashboards and what have you. So now the new way, all employees work with office productivity systems, and operational users also require decision support systems to aid them in how they do things. So now we also have a new set of definitions, such as enterprise computing systems, TPS or transaction processing systems, business support systems, knowledge bases or knowledge management systems, and user productivity systems. Enterprise computing: information systems that support a company-wide operation and data management requirements. For example, Walmart's inventory control system, or Boeing's production control system, or the Hilton reservation system. I could also say another example would be the Albertus Magnus student information system. Applications called Enterprise Resource Planning, or ERP systems, provide cost-effective support for users and managers throughout the company. And these ERP systems, or enterprise systems, they do really involve all scopes and all aspects of an institution. Transaction processing systems are just what they sound like. Those are systems that handle day-to-day transactions, customer order processing, accounts receivable, a warranty claim processing system. A time clock system might also fit into this. A transaction processing system verifies customer data and checks customer credit, stock status, and posts to account receivable, adjusts inventory, that sort of thing. So here's a little chart you can look at where it's got several different tasks that are all part of the sales transaction and thus part of the transaction processing system. Now we also can look at business support systems. These provide job-related information support to users at all levels of the company. It can work hand in hand with a transaction processing system. And one new development here is the RFID chip. And we see this with our credit cards now more and more. And I'm sure you've seen your credit cards. I'm sure you've bought things at Stop and Shop or what have you with the RFID chip. It basically uses high frequency radio waves to track the physical objects, and you can see the different identifier chips in your ATM cards, your credit cards, what have you. A lot of benefit with inventory control with RFID as well. Knowledge management involves the use of large database called a knowledge base, and these are also called knowledge base systems, and I've heard it referred to interchangeably. This allows users to find information by entering keywords. User inference rules, which are logical rules that help identify patterns and relationships. When I was working as a tech with the student information system that Albertus used, I would rely on their knowledge management system, and I would search keywords that helped me with my problem, and it would help me to determine what was going wrong. It would help me find the issues. So some institutions have very good knowledge bases or knowledge management systems. Some are not as good as others. But this is an important aspect and definitely something that we need to learn. Okay, now we'll continue on with user productivity. Technology that improves productivity, quite simply. Groupware is an example. And systems integration. Most large companies require systems that combine transaction processing, business support, knowledge management or knowledge base, and user productivity features. In the next chart, we can see a typical organizational model, and we can identify business functions at the various levels. So these are the different functions within the business, and you have all of these functions that are used at the various levels of the organizational pyramid. Top managers develop long-range strategic plans, which require a decision support system, which define the company's overall mission and goals. The need for information and economic forecasts, technology trends, competitive threats, and governmental issues are the types of issues and trends and information that top managers are concerned with. Middle management and knowledge workers provide direction, necessary resources, and performance feedback to supervisors and team leaders. The need for more detailed information than top managers. In other words, the middle managers and the knowledge workers are required to take the vast amount of information and summarize it and make it concise, because that's not something top managers have the time to do. So middle management decisions can have a lot of impact on the upper management. Supervisors and team leads, they oversee the day-to-day operational employees and carry out day-to-day functions. They need DSS information, knowledge management systems, and user productivity systems to help them work with their teams and what have you. So supervisors and team leads might be like head clerical people. They might be the person in charge of the financial aid office. Maybe they're the people in charge of the business office, that type of thing. Operational employees are the most reliant on the transaction processing systems. They are the data entry people who are being supervised by the supervisors and the team leads. Now let's talk about systems development tools. So there's different types of modeling here. There's the business model, a requirements model, a data model, the object model, the network model, and the process model. This picture here shows Microsoft Visio. I would love to be able to use Visio for this class. However, I don't know that we're going to have the ability to do that, and with the online students, I can't guarantee that you're all going to be able to have that. So keep in mind that Microsoft Visio is an excellent visual tool. Now we'll talk about prototyping. It's the early working version of an information system. It speeds up the development process significantly because important decisions might be made too early before businesses or IT issues can be thoroughly understood. So you might think of prototyping a system as a proof of concept. So it should be based on careful fact-finding and modeling techniques, and it can save you a lot of headaches down the road. Computer-aided systems engineering, or CASE tools, provide an overall framework for systems development and support a wide variety of design methodologies such as structured analysis and OO analysis. It can generate program code, which speeds up the implementation process. So CASE tools can be used to generate program code very quickly and easily. You might hear of code generators or computer generated code. These are often created through CASE tools. Sometimes you need the CASE tools to be able to read this program code as well. That's an important consideration to mention. Systems development methods. This includes structured analysis, which there's the traditional method for developing systems, and it's organized into phases. So structured analysis is the most common method. The OO method is a more recent method for developing system. Objects represent actual people, things, or events, and with this we can look at the inputs and outputs from these actual objects. So the latest trend in software development is a team-based effort broken down into cycles. This is the agile methodology. I've had issues with this a lot of times with the different types of meetings that you have, like the daily stand-ups if they're kept within the constraints that the Agile methodology is set up to use, and the Scrum Master, which we'll get into more later, is effective and good at keeping time under control, then Agile can be successful. However, I've seen this go so badly, and I've written a paper on this actually as part of my master's, and I'm thinking about sharing that paper with the class. Agile can be very powerful. I've also seen that go the other way, though. Now let's talk about structured analysis. It's time-tested and easy to understand. Earlier we discussed the systems development life cycle. This is where it comes in to play. It uses a predictive approach. In other words, we predict what's going to happen. It uses models to describe a system graphically. Here's a very simple example of a school registration system where we look at the inputs, which are the students, the courses, and then it goes through registration, and the output is the roster that gets created. Very interesting concept. That's structured analysis. The SDLC includes 5 primary steps. There's the planning, the analysis, the design, the implementation, and the security and support. I like to work with security into the implementation a little bit. That should be taken care of ahead of time. However, security and support are ongoing, and this last step really is the ongoing step once it's a fully operational system and it's been sent out there. So those are the 5 steps associated with the SDLC. Object-oriented analysis combines data and the processes that act on the data into things called objects. So in this example here on the diagram to the right, we have person, instructor, and student. Those are objects. Objects are members of a class, which is a collection of similar objects. Built-in processes called methods can change an object's properties. One thing that's important to think about with object-oriented analysis is the concept of inheritance. In this example here, the person object, or the person class, contains the name, address, and the date of birth. This information and these objects are inherited by instructor and student, so they're considered inherited properties. A student will have a GPA where an instructor will not, and an instructor will have an office location where a student will not, so those are other properties. The object-oriented methodology provides an easy transition to object-oriented programming languages such as Java, such as C++. There's many object-oriented languages, and that's really the direction that we're going these days. Now we'll talk about the Agile methodology. The newest development technique as systems are developed incrementally. A series of prototypes are built and adjusted to meet user requirements. As the process continues, developers revise, extend, and merge earlier versions into the final product. Agile method emphasizes continuous feedback and iterative development. Actually, that sounds like an ideal world. Has a lot of considerations that I have not seen because, like I said, there is what's called the Scrum Master who does control all this, and it can get out of hand if you're not careful. So Agile methods are processes that determine the end results. Other adaptive variations and related methods exist. 2 examples are Scrum and Extreme Programming. And I've seen combinations of both, where extreme programming is the idea that you have sprints, and you rush to get your code written in a small amount of time. So one thing it mentions here that is important is analysts should understand the pros and cons of any approach. If you're going to use Agile,
like I said, and you're going to work with Scrum, make sure you have a good Scrum Master. That's my best advice. Other development methods where teams consist of IT staff, users, and methods are the joint application development, which focuses on team-based fact-finding, and rapid application development, which is a compressed version of the entire development process. The systems development methods also continue on with developing a project, involve users and listen carefully to them, use project management tools and identify tasks and milestones, develop accurate cost and benefit information, and remain flexible. These are some of the different roles that exist within any IT department. I should say, in an ideal situation, these are the roles that might exist. This is one of my other issues, is not every institution will have a set person for each one of these specific roles here. The information technology department's roles, I'll discuss them now. There's application development. Systems are developed by teams consisting of users, managers, and IT staff members. Knowledge, skills, and education. Need technical knowledge, strong oral and written communication skills, an analytical ability, and an understanding of business operations. And certification, important credential, depending on the person. It can be a useful tool. I've seen many people in my career who have what is referred to as the paper MCSE. Somebody who has an MCSE, which is a Microsoft Certified Software Engineer, or MCNE, which is a Microsoft Certified Network Engineer. Those are fantastic certs to have, but there are a lot of paper certs out there. In other words, those are people who've crammed and studied for the tests, but who don't have the hands-on skill. So certification is important, but it's not as important as hands-on work as far as I'm concerned. Application development, system support and security, and user support are other responsibilities. I'm not going to go through this in too much detail. The database administration, or the DBA, handles the database work. The network administrator handles hardware, software maintenance. They're usually Cisco certified if you're concerned about certifications and what have you. Again, there's a lot of paper Cisco certs out there. Web support, those are specialists who work with the HTML, who manage the web traffic. It might be a busy website that gets a lot of traffic. You'd have to manage the web server farm and organize how the traffic is directed to the various web servers. And too many technology departments do not have a QA department. Programmers should test their own work to a point, but you should not count on a software developer or an application developer or an application engineer doing their own QA, because they look at what they think to look at and they won't think outside the box. And that's not an insult, but quality assurance is an important role that many IT departments overlook. Let's break down the SDLC a little bit into the systems planning. I'm going to go through these next slides a little bit quickly. There's the systems request. This begins the process and describes the problem or desired changes. I've never really gotten a systems request. It's always been a discussion. It's been something that's been known about. It's been something that's never been formally presented to me the way it was in this textbook. I think this textbook gives you an ideal situation here. That being said, the purpose of this phase is to perform a preliminary investigation. This is critical. And the key part of the preliminary investigation is a feasibility study. And that's to see if this project will even be worth it. It might not be. There's a lot of considerations that go into the feasibility study. Next, we have systems analysis. This is where we build a logical model of the new system. We perform fact-finding techniques, which we're going to go into in much more detail. We build business models, data and process models, and object models. The deliverable is the system requirements document in the systems analysis phase. In other words, the systems analysis is where we go in, we do our fact finding, we do our research, and then we prepare our analysis and we put it on paper, so to speak. Next is the design phase. This is where we create a physical model that satisfies all of the documented requirements. We design a user interface. That interface, if it's from a vendor supplied product, it may be supplied. You're still going to have design considerations. You're going to have to identify the outputs, inputs, and processes, and this is a very, very important step right here. Many of these ERP systems have a lot of different inputs and outputs going on and happening day to day that you need to be aware of, and that's something that you should take care of in the systems analysis phase because it's going to come to fruition here. The deliverable is the system design specification. Okay, management and user involvement are critical. That's where the systems analyst comes in. You function as a liaison in all the processes here. The systems implementation is the actual creation of the new system. Programs are written and tested. Sometimes they're rewritten and tested. A system is installed. Deliverable is completely functioned and fully documented. This is ground zero. This is where the product, once this phase is completed, this is where the product is delivered to the customer or the end user. After this, system support and security must be maintained. You're going to have users come and go. Their security is going to have to be updated. You're going to have new business specifications where security is going to need to be maintained. And you're going to have issues. And when I say issues, I mean bugs that are going to come up, and you're going to need some sort of a support system to address these issues when they come up, and it's inevitable. Now we're going to continue on with object-oriented analysis. Please go through the role of the systems analyst, look at the career opportunity slide following, and review the chapter summary of what we've discussed here. Please go through the slides in the book to address any other questions that you may have. Thank you.